All right. So I'm going to share my screen now with you, and I'm going to use the collab environment. This environment is called the collab environment. And how do you get there? You get there by typing collab.research.google.com. You know, can you see that? Okay. Let me move this guy away so that we can see this screen very clearly. All right, this is it here. That's the URL. Normally, we believe that you have your account with Google. If you have your account with Google, it's very simple. If you have a Google accounts will give you opportunity to use the cloud. You know, they have the Google Doc for you. The Google Sheet is there for you. Google Colab is another package that is there for you, which is dedicated for running Python online. You don't have to install it on your computer. But to use Google Colab, you must have access to the internet anytime you want to launch your Google Colab. So Google Colab will not bother you to install any package. Any package whatsoever you think you want to use. They have apparently installed the basic packages you will need to do whatever you want to do. But in a situation where you don't have it installed, you can also still install your package in the Google Colab environment. So in this environment, but the only disadvantage is once you are working on it, you have to copy your work out or save it in another folder. Because within 24 hours, whatever file you have saved, I'm not talking about your code files, any file whatsoever you have generated maybe as an output, you won't find it again after 24 hours. It will have been, cleaned up within 24 hours. So, but then you can save it and put it elsewhere. That's the only thing. But then it, for me, is very portable. It's very flexible. You can run it even on your phone. While you are lying down on your bed, you can be running your codes on your phone. And I think this code, I wrote it while I was on my bed, on my phone. So I'm just going to take us through that. So what this is going to do, it is going to ask us for, I think it's going to, I have dedicated, I've configured this age to be 5. This is just like a constant now that I have used here. I think this is into about two categories. I'm going to begin to explain line by line. Now you can see import math here. I'm going to tell you why I've used the word import math. There are some, ordinarily, your NumPy is a package that is used in Python as well. Anaconda, Panda is another package also that is also used for analysis in Python. But there are some mathematical equations, mathematical formulas that are embedded in math package, which you have to import. You only import what is already installed on your computer. So we believe that because we are using Colab, if it were not to be Colab, if you are going to do this on your local system, you are expected to first of all do PHP install, PIP install that package before you can do anything. But in this case, it's already installed on Python. So what you're going to do is you're going to invoke it, calling it to the memory so that you can begin to use the functions that are attached to math. So here I have declared age like a constant. Let age hold the value 5. I've also declared num1 as in another number as 25.9, which is like floating point. Then I've also declared another num2 as a variable, as a discrete number 10. So with this, I can begin to do manipulations, use Python as calculator as it is. If you are looking for a calculator, you want to do some mathematical formulas, you want to multiply some things, you want to add so many things together. Like we have said, I told you that you should listen to my video on R, where I've talked about data structure, where I've talked about mathematical operators that is used in programming. And I think that's what we're going to be using here now. Here now, if you look at this number represents a numeric. Numeric, why? Because it's carrying numbers. And then it's also discrete in nature, which means it's an integer. An integer is a whole number that does not have any value. Don't mind to say that. All right, so this is where we are. So this is floating points because it has remainders, it has points, just like the name implies. That's floating points. I've declared that. So this is ordinarily you are expected when you are doing operations like, take for example, now if I just want to add I want to add number 1 num1, if I want to carry out mathematical operation like addition, and then num2, don't forget this is case sensitive as well. You just run that. If I put this together, let's see what we're going to get. Why is this giving me this? I don't have to. I'm not here yet now. Okay. Okay, so let's see. Okay, let's put the result. Let's take, for example, that what we want to do now is we want to square num1. Num1 here is 25.9, which is you can represent that by double star. Star is raised to power. That's what we have. That is the way to indicate num1 in Python. So also in R is the same thing. When you want to say num1 raised to power 2, that's what we want to do. So it's going to carry the value in num1 and put it here. And the result is going to give us will be the square of 25.4. So we're going to see that result now. Once we click here, let me run from this point. I don't have to import now because the import there is only useful for my square here, which I do not need now. So let me just show you. Let's stop from here. Let's see what this is going to give us. I'm not here yet. This is not what I want to run now. Okay, let me copy. Now you can create a number of instances. You can create a number of instances. Let me copy this out. You can create a number of instances. Let's say I copy this out. Click here again to copy another instance, to create another instance. So I can put that here. Oh, sorry. This is not showing. Okay, let's just say num1 is equal to 5. Num2 is equal to 6. And then we can say num1 plus num2. That should give us, let's see what that we're going to have. Let's just run this. It's already running. It's giving us a report, but we don't ask it to print anything. We have to put the answer in a container. Like we have here, we have to put the answer in a container. So here, let's say the answer is okay, answer. Let's put the answer here. And let's see what we're going to have. Let me stop this. Ready. So let us now see what the answer will be. Because you need to get the output here. Let's see what we're going to have. Okay, it's there now. The answer is here now, because ordinarily what we're asking it to say is to print answer here. If you look at that, this 5 plus 11. In the alternative, you can also say that if you want to do, maybe you want to subtract one number from the other. Let's say this is what we want to do. Let's see what the answer is going to be. It's going to bring out the answer here as well at -1. That's correct. We can also say that maybe you want to do division. Let's see what we're going to do. This is how to do division, just like that's another operator also in R, which is also synonymous with what we do in Python as well. So that. It has done that for us. We can also square it. We want to look at the square. Let's say we want to square a given number. You can decide to say, let's square number 1 star 2. And let's see what the answer will be at the end of the day. You see what we have done? We have just raised number 1 to the power of 2 and then divide the answer by num2. So we can also say that we want to find the square root. Square root, you won't find the square root ordinarily as it is. You have to, it's embedded in import in a math package. So you have to import that, import math. So when you import math, you will now ask it to use it from here. Let's say we want to find the square root. Math dot square root, SQRT. I think the answer, let's see what we're going to have. So answer, at the end of the day, we are going to put that in a container. Let's say the answer, final answer. Okay, square root. This is just my own coinage. Root. This is my own coinage where I want the answer to be. So I'm not going to put this here again. The answer should just be there. So let's see what we're going to have. Oh, okay, we still have to print the answer, you know. Let's say we have to print the square root. It has done it and it's keeping it to itself. So let's ask it to bring it out. You can put print, but then why do we want to waste words? I'll just say, okay, that is that. You can see what has happened now because I needed to use the square root. I can't use the square root ordinarily like I would use ordinary numbers because this is a function within the math package. It is because if we did this without saying import math, it won't see that it won't see this SQRT. Same also if you want to say, we can say math dot cos. Let's say cos. These are the things. These are some of the things cos. Maybe cos 60 or let's make this one cos. We can type cos 60 if you like, but let's put 60 here if you like, and let's see if you still remember your trick. You will now put num 60 here. No, num 2 rather, which represents our 60. So we can then ask it to say, okay, what is the output of that? Let me call it output. You know, this square root, we don't need that yet. And I think we also comment in Python. Once you put hash there to comment, you put hash to comment something out. That way, the Python interpreter will not read it, you know. Python interpreter. So I am suspending this square root file name now so that you don't read it. So what we're going to do now is we want to get the output of this. We want to see the cos. We want to see cos. What is the output of cos number 2, which means cos 60. You know, so let's see what we're going to get. It's done. Okay. You can see the reason why. Can somebody tell us the reason why it's not showing us the results? If you look at this place, it's already checked. The runtime is 0 seconds, which means it has run. We don't have any challenge with the codes. It's run successfully. But then can somebody just tell us why?
You need to call the outputs.
Thank you so much.
To return the result.
Fantastic. So we are going to just call the output to return the result. I put this here, put this there. So if you just click this one alone and ask it to just, let's see, maybe if once you hover your mouse on it, can you see? It's telling us the output already. Once you hover your mouse on it without even running it, it's telling us the output. Let's see. Well, let's run. So the output is minus 0.95. So we want to know what I think, let's say tan theta, what's tan theta? Let's say tan 90. Let's make this one 90. And then what is tan 90? We used to know it when we were doing trig. I don't know what that thing is now. What is tan 90? Can somebody tell us before we get the answer? So what I'm doing here indirectly is looking for tan 90. So let me run this and let's see what the answer will be. Can you see this minus 1.90? That's about 2. So, and so many things. You can also combine it. You can combine with so many things. You can put that now and then say plus, what is our square root? The square root here is also another output, which you can put here, as simple as that. And once you run that, the general output is going to come out here. Let's see what this is going to give us. Let's run everything all together. Can you see the answer is different now from what we got in the beginning? So with this, there is no mathematical formula you cannot express. There is no mathematical formula you cannot undo. Once you can express it on a straight line, and what do you want to do? What you want to do is square root. Is that you square or you do the reciprocal? The reciprocal is also, okay, let me find the reciprocal of this, our output now, which is also just 1 over something. These are the things that you do in mathematics. You do square root, you do square, you do tan theta, you do cos, you can also do log. We can log it. Okay, let me log. You can log, you can do so many things. So all of that are embedded in math package. If you did not import this math package, you wouldn't have been able to get all of these things done. So I want to do reciprocal now of our final output. Let me say reciprocal, which is the inverse of that number. It's going to get it done, but let's say inverse. This is just my word, my inverse. Okay, that is just my word. We are putting the output of 1 over output inside that my inverse. So let's run it and let's see what we're going to get. So it has done it successfully, but then it's not giving us any answer because we did not call it out. to give us the final answer. So this is what we have to do. Okay, that is that. Let's see. If you just over this mouse on it, it should give us the answer. Yeah, 0 minus 0.68 or something. So that is it there. It's as simple as that. Minus 0.681127. So the same way when you want to do this, what do we call it? This arithmetic general formula for quadratic equation. Minus b plus or minus square is b squared minus 4ac over 2a, which is, it means you can write a code to solve that as well. And if you want to write a code to solve that, how do you go about it? Can somebody tell us? We're not asking us to use we're not asking us to use factorization, but rather we want us to use what we normally call almighty formula, which is usually called general formula, which is minus b plus or minus square root b squared minus 4ac over 2. So if you have an equation like this, a quadratic equation, write a Python code for quadratic equation. How do we go about it? So I just need 1 or 2 explanations, and then we can begin to experiment. And I will leave that with you. And then when we come back, we do a few other things. Anybody that wants to help us? Like I said, all you need to do, once you can express it on a straight line, you can achieve it. Yeah, anybody? You want to tell us what to do? You just chip in 1 or 2 things as regards how you think we can get it done. Anybody? Don't forget our quadratic equation is like x squared. Let me use s squared. You know, I can't type squared there. It has to be like this minus, let's say, what is the factor of x squared minus 3x plus, let's say, plus 1. Yeah, you know, normally they say is equal to 0. That's an equation. We can also have another equation, a second equation. Let me say this is the first equation. I'm not running this as it is. I'm just going to comment it out to show that I'm only writing out I'm still going to write out the code to get this done rather. So let's say this is x squared also, and then this is 5x. Is it 5? Let's say this is 6x and then plus 5. So these are 2 equations we want to resolve. Yeah, that is it here. How do we go about it? What's the approach? Okay, can I quickly assist you if nobody's ready? Okay, Oluwafemi, you want to help us?
Okay, let me just say, from my own experience from the R points.
Yes.
So maybe we are going to write a function, and in that function, we consider all the arguments, the inputs that will go into that function. That is how we can achieve the quadratic applying it to Python in the Python way.
Okay.
I don't know if I'm correct.
You just try, but you did not simplify it. So I want you to simplify it to somebody who is just learning. You know, if you look at that, okay, you have tried. It's a good try. What now? Saving here in this platform on this collab. If you look at this top right here, where I just over my mouse, the extension for collab is IPYNB. So your name is this. Your file name is this. So I'm going to call so that I can fall back on this when I get back. Let me click on you don't have to save it. You save it automatically by itself. That's what it does when you're working in the cloud. What do we call it now? Okay, Python. The first thing you want to do is you want to say that A, let's put A, we are going to get a value A. If you remember that formula, the coefficient of A is here. The coefficient of B is here. The coefficient of C is here. So we are going to have 3 values, A, B, C. So your A, sorry, don't mind that, boy. Your A is equal to this, and your B is equal to this. Our A in this case is what? What is the coefficient of X here? Is 1. In equation 1. The coefficient of X in our B is what? Is minus 3. And the coefficient of C here is 1. Can you see that? So this is the first thing you are going to do. This is the first thing you are going to do. Do you understand the way I've extracted that value? The same way is what we're going to do for the second one. If you want to extract the second value, what will be the coefficient of x here? What will be our A? I want your response. For this second equation, what will be our 1? Fantastic. What will be our B here? In this second equation?
6.
Fantastic. -6.
-6.
-6. Thank you. What will be our C here?
5.
5.
5. Fantastic. So we want to deal with the first equation. So what we have to do is, don't forget, we have this B squared. That's the internal one. The internal one. We could normally call it. That's the name we normally call it. I'm treating the numerator now, not even the numerator. You know, we have minus B. Let me write the formula. Minus B plus, you know, we can't write plus or minus on the screen, so you have to get 2 answers. What plus or minus means is you're going to get 2 answers. Let's write the positive part first, which is plus minus B plus some plus square root B squared SQRT. But don't forget, our SQRT is going to come with math dot SQRT B squared. Is that not? B squared is what? Star 2. That's minus B plus square root B squared. That's the first thing. You know, don't forget, we are still going to have, we are going to do this one for the negative side as well. So we paste this minus B, then the negative side is